Here we're dealing with a quadratic sequence, and there's something special about quadratic sequence, and I'll show you what that is. So if I find the first difference of a quadratic sequence, that means I'm finding the difference between the terms. So 0 to 9 is 9, 9 to 22 is 13, 22 to 39 is 17, and I can see that it's not constant like it is for a linear sequence, it's actually going up. But in fact, it's going up by a constant, so I can find the second difference, which is 4. So first difference, second difference, actually the first difference is a linear sequence. How does that help us? Well, what we can do actually is we can take the general form of a quadratic sequence and we can substitute in for some values of n to get the first few terms and then use this information. So when n is equal to 1, we're going to get that the first term is a plus b plus c. This is actually the procedure I would expect you to do for this question. And it's once you practice it, I think it's not as difficult to remember as some other methods for quadratic sequences. When n is 2, I got a times 2 squared. That's 4a. So it's going to be 4a plus 2b plus c. And then I'll find the third one as well. That's going to be when n is 3. I'm going to get 9a plus 3b plus c. Okay, that's my quadratic sequence algebraically. Now I'm going to find the first difference. This first difference here is going to be 3a plus b. That's the difference between the first term and the second term. Then the first difference here is going to be 5a plus b. And then I'm going to find the second difference, which is going to be 2a. I don't need to find any more. I can see that I just know that's going to be the case. You can check if you like, but the second difference is equal to 2a. So I'm in a great position now because it must be that 2a is equal to 4. And therefore a is equal to 2. Right, what next? I know that 3a plus b is equal to 9. But I now know that a is equal to 2, so I can write down that 6 plus b is equal to 9. And therefore b is equal to 3 by subtracting 6 from both sides. And finally, I know that a plus b plus c is equal to 0. So 2 plus 3 plus c is equal to 0, and c is minus 5. And we're done. You could, if you want to, you could check this now. So I know, it doesn't say it, but my quadratic sequence is going to be 2n squared plus 3n minus 5. And we could substitute some values in for n. We could actually, if we want to check a lot of them, we could actually use the table function, and in place of n, I'm going to use x. This is going a bit overboard. You could just substitute a few values in, but 2x squared. This is a function that will do it for lots of different values of x if I wanted to. We're only interested in whole numbers here, 1, 2, 3, 4, 5, 6. Okay, if I start at 1, end at 1, and here we go, 0, 9, 22, 39, and I could find more terms if I wanted to. So I'd be really happy with this at this point, that I've done it correctly.